Okay, problem number 5 is division, and this is different than problem number 4. Problem number 5 says divided by a binomial, which means 2 terms. Problem number 4 said divide by a monomial, which is 1 term. So when you divide by a binomial, you can use long division. So I set it up on the right here as long division. Now, what I'm going to do is I'm only going to look at the first term of each. And I'm going to say, if I were to think of it this way, to ignore everything else, what times z will give me 2z squared? Well, that's going to be 2z. I put that here. Okay? That's the divide part. Then I say, wait, just like in long division, I actually multiply, though, now what I have in reality. So I'm going to say 2z times z minus 9. So that's going to be 2z squared minus 18z. I'm just distributing. So I write that underneath my dividend. Okay? Now next, we know in long division, we subtract. Okay, so I'm going to subtract the top row minus the second row. Okay? There's an easy way to do this so that you don't forget to distribute that minus. One thing you can do, instead of writing that, is you can just change the signs that you see in the second row. Let me get a different color marker. So in other words, it's an easier way so you don't screw up the signs. Write down whatever you have and then just change the sign of each. So it was a positive, now it's a negative. It was a negative, now it's a positive. And then add vertically. Okay? Now the next thing is you're going to bring down. And then you start the whole process again. We're going to start with those first 2 terms. So z and negative 16z. Right? That's all this one and this one. What times z will give me negative 16z? Well, that would be a negative 16. So I put that in my quotient. That's my divide part. But then I said, wait, I have to actually multiply what I have. So we're going to multiply negative 16 times z minus 9. And that's going to be negative 16z. And then 16 times 9 is 144. So that's going to be 144. Okay? So I write that down. Okay, and I can subtract. But an easier way, I told you, is to change both signs. So this is going to change from a negative to a positive. And this is going to change from a positive to a negative. And then you can just add vertically. So I get 0. So my answer is 2z minus 16. Number 6, factor by grouping. So we wanted to factor by grouping because we know we have 4 terms. And the first thing we're going to always do is check for a greatest common factor. So the way we check for a greatest common factor is we put the prime factors above each term. So this would be 3, already prime, and an x and an x. And this is a 3 times 3 times x. And this is 5 times x. And this is 3 times 5. So if you're not sure where you get the prime factors, for like 15, it's the bottom of the tree, that bottom row of prime numbers. And then step back and say, what do you have in common in all 3 or all 4 terms? Well, nothing. So you don't have a greatest common factor, but you would always check that. Okay? So there is no GCF, we checked. Now, since there are 4 terms, 1, 2, 3, 4, we know to use factor by grouping. And factor by grouping just means you're going to take this and you're going to divide it into 2 mini problems. Let's get a different color marker here. Okay? So in other words, you're going to take this and you're going to divide it right down the middle here. And we're going to pretend we're going to do just the left side and we're going to do the right side. Okay? All right, so if I just pretended about the left side of the problem, ignoring the right side, this would be, I had this, and I have this as far as my prime factors. All right, so just those first 2 terms, is there a greatest common factor? Well, sure, you can see they both have an x, and they both have a 3. So my greatest common factor is 3x. It's whatever's circled in one term. And whatever's not circled can go in the parentheses. So you see there's an x, and then you match the sign, and then there's a 3. So I have factored the greatest common factor out of the first 2 terms. Now I'm going to look at the third and the fourth term, and I'm going to do the exact same thing. I write my prime factors above it, and I say, oh, they both have a 5. And that leaves me x minus 3. Okay? Now, once you have them factored, you're going to reunite them. Well, since that's a 5 and it has no sign to the left, we know it's plus. Okay. Now, what you want to do is you want to ask yourself, what is your greatest common factor? Okay? Well, you can see that this first term is made up of a 3 times an x and then times the quantity of x minus 3. The second term is made up of 5 times the factor x minus 3. So x minus 3 is the greatest common factor, and it's going to always work out that way. That's the whole idea of this, when you can greatest common factor. So I circled it, and just like before, whatever I don't circle, I put inside my parentheses. So that is the grouping, a factor by grouping. Now, if you wanted to check your answer, you want to make sure you get this right, you can always check it by multiplying. So I'm going to multiply. And I'm going to combine like terms. Well, and actually, you don't have to reason. I'm looking at the problem, and they left it like this for the original problem. But the whole idea is when you multiply it out, you want to make sure that you get the original problem, because that's how you're going to factor it correctly. Okay? Problem number 7. Another one, factor by grouping. Okay, let me erase it. Okay, so the first thing we're going to do is look for the greatest common factors. I'm going to write the common factors, the prime factors, sorry, above each term. So to get a 20, that's a 5 and a 4. So it's going to be a 5, a 2, and a 2. And a y, and then a 7y, and then to get a 28, you could do it, it's going to be 2 times 2 times 7. Now, if I look, but there is no greatest common factor of the 4 terms, so I can't pull out a greatest common factor. But once again, since there are 4 terms, I'm going to divide them right down the middle, okay? And I'm only going to look at the 2 on the left. So the 2 on the left, my first 2 terms, I can see that there's a greatest common factor of 5 and of y. So my greatest common factor is 5y. That leaves me uncircled with a y here. I match the sign, and then a 2 times 2 is 4. Let's see the one on the right. For the third and fourth term, I have a greatest common factor of 7. That leaves me with a y plus 4. Now I reunite the 2 problems. Now the greatest common factor now is y plus 4. So we write that in the front. And then whatever's left over, we write inside the parentheses next to it. Now, here's some warning on the test. If you do not put parentheses around the front factor, it's going to mark it wrong, okay? Because it needs to know that you know that the whole thing is a factor, and it's not y plus the quantity 4 times the quantity 5y plus 7. So please remember to put these parentheses around that front factor when you put it into iMathAS. Number 8, factor the polynomial completely. Okay, so we have a polynomial with 2 terms. Any polynomial that we want to factor, we always want to start the same way, which is greatest common factor. You can use your calculator to see, what the divisibility rules are. For this one, I probably would instead just try a 2 and see where that gets me. But if you're not sure, you can always write the prime factor tree. So it'd be what, 2 and 1. What's that going to be? 47. And that's going to be 3 and 49. All right. So you can see, and then 6 will be 2 and 3. So the greatest common factor they're both going to have is a 2 and a 3. So I can take out a 6 out of both of these because 2 times 3 is 6. And I'll be left with 49p squared minus 1. Okay? Okay, so now I've taken out the GCF, right? The greatest common factor, And now I'm left with two terms. Whenever we have two terms, we're going to look and see whether we have a difference of squares. A squared minus b squared, you need to memorize, is a plus b and a minus b. So you're going to want to add that to your brain dump so you memorize it. So we see that 49p squared minus 1, you could rewrite it as 7p all squared minus 1 squared, because 7p times 7p is 49p squared. Okay? If I'm not sure of that, I can take the square root of 49, and that would give me 7. So that means that I'm going to write 7p plus 1 and 7p minus 1. Now, some little warnings of things I do. If I did this problem and I were on